All right, today we are diving into a huge breakthrough in artificial intelligence that could, and I mean really could, change medicine as we know it. It's called BiomedCLIP, and it's a new AI that's basically learning to read millions of scientific images and texts. So let's get right into how this thing actually works.
To really wrap your head around the scale of this, just think about this for a second. What if an AI could just absorb the knowledge from millions of medical journals, images, and charts, not over a lifetime, but in a matter of days? That's the kind of massive leap we're exploring right now.
But, to even get close to that, researchers first had to solve this giant problem. For years, medical AI has been kind of like a genius student who's stuck with the tiny, totally outdated library. All the potential in the world, but nothing to learn from. And here's the kicker. The problem wasn't even the AI algorithms themselves. Nope, it was the data. Most medical data is, for very good reason, locked away because of patient privacy. And the public data sets that were out there, they were tiny and super specialized, focusing almost entirely on just one thing, like chest x-rays. You just can't train a true medical expert on such a narrow curriculum. It's impossible.
Just to put a number on it, one of the biggest public datasets before all this had around 377,000 image and text pairs. Now, that might sound like a lot, right? But as it turns out, it wasn't even close to being big enough, not by a long shot.
So the very first part of the solution was to just build a brand new library from scratch. A massive, public, and incredibly diverse library built specifically for an AI to study medicine.
And here is the new number. Researchers built this dataset called PMC15M, and it has 15 million image and text pairs. That's not just an upgrade, that's over 40 times larger than what we had before. We're talking about a totally different universe of scale here.
And get this, it's not just about the size, it's about the variety. This new library is unbelievably diverse. We're talking more than 30 major biomedical image types, everything from microscopy and CT scans to complex charts and graphs. This variety is absolutely the key to training an AI that can understand the whole breadth of medicine, not just one little slice of it.
So, to sum it all up, PMC15M is a total game changer. It's a public resource, which means no privacy headaches, and it's built straight from the figures and captions of millions of peer-reviewed scientific articles. It really is the ultimate open-access medical library for an AI.
Okay, so with this incredible world-class library now in place, the next step was to create the genius student to read it all, a new AI model designed from the ground up for this exact task.
So, let me introduce you to BiomedCLIP. Now, it's built on a super powerful AI from OpenAI called CLIP, which is already fantastic at connecting images and text. But BiomedCLIP has this one critical twist. Instead of a generic text reader, it uses something called PubMed-BERT, an AI that was already trained on millions of biomedical articles. It's like it already speaks the complex language of medicine, so it understands all that scientific nuance right out of the gate. A great library and a genius student. It all sounds good in theory, right? But does it actually work? Well, it was time to put BiomedCLIP to the test with some really tough exams.
So the first test was pretty straightforward. Give the AI a complex medical description and see if it can find the one correct image out of thousands. The standard CLIP model, it really struggles. But just look at BiomedCLIP. It finds the correct image in its top 5 guesses more than 77% of the time. That is a gigantic leap in performance. And we are not talking about simple descriptions here. I mean, look at this. This is the kind of super dense, specific language the AI has to understand. Can it really get what spindle cells and myxoid stroma and hematoxylin and eosin staining means, and then find the right picture? Well, let's see. When you give it that exact prompt, the general CLIP model just returns these generic, totally wrong images. It gets completely lost in the jargon. But BiomedCLIP? It absolutely nails it. It finds the correct image, and its other top results are all highly relevant images of the exact same cell type. This right here is the difference between just guessing and actually understanding. All right, for the next test, the researchers set up this classic underdog fight. They put BiomedCLIP, the generalist trained on over 30 image types, up against BioVil, which is a state-of-the-art specialist AI trained only on radiology images. The challenge? Detecting pneumonia in chest x-rays. This is BioVil's home turf. And here is the total shocker. The generalist won.
Even though BiomedCLIP had this much broader education, its diverse training actually made it more robust, and it outperformed the specialist in its own specialty. This just proves that learning from a wide range of medical data creates a much more powerful and adaptable AI.
But hold on, the story does not end there. All of this power unlocked this unexpected, almost magical new ability, a way to analyze private patient data without ever actually seeing it.
Okay, here's how it works. A doctor has a private scan from a patient. Now, instead of sending that scan to some external AI, they use BiomedCLIP to find the most similar public images from its huge library. These public images, which are called proxies, are then sent out for analysis. The insights come back to the doctor, but the original patient's data never, ever leaves the hospital. It's just a brilliant way to use these powerful tools while keeping privacy totally locked down.
And get this, it's incredibly accurate. When they tested this proxy method for detecting a condition called atelectasis, that's a type of lung collapse, the accuracy was over 95%. This shows that the public proxy images are good enough to give real, clinically useful insights. It actually works.
So what does all of this really mean for the future? Well, we are witnessing a fundamental shift in how medical AI is even built, from the ground up.
The big takeaway is this. By solving the data problem first, with a massive, diverse, and public library, researchers have laid an entirely new foundation for a true generalist medical AI. BiomedCLIP isn't just another model, it's a whole new starting point for the entire field. Which of course leaves us with this final amazing question. For the first time, the idea of a single AI model that could master the entire vast landscape of medicine, from radiology to pathology to genomics, it just doesn't seem like science fiction anymore. The question is no longer if it will happen, but when.